the Smart Buildings Academy podcast with Phil Zito, episode 453. Hey folks, Phil Zito here, and welcome to episode 453. In this episode, we're going to be diving deep into BACnet IP. We're going to look at BBMDs. We're going to look at BDTs. We're going to dive into Wireshark. We're going to do a pretty deep exploration of BACnet. So this is going to be a fun one, and there's going to be a lot of information here. I will say this is going to go pretty deep. So for those of you watching live, please use the chat feature. If there's anything that's unclear, let me know. Sometimes I have a tendency to mispronounce acronyms. Let me know if I do that. Sometimes I'll mix stuff up. It's just kind of after you've done as many episodes as I have, you make those mistakes. Everything will be available at podcast.smartbuildingsacademy.com/453. Once again, that's podcast.smartbuildingsacademy.com/453. So if you're listening to this after the fact on iTunes or Spotify, go to that link. You'll be able to watch the video recording. You'll be able to kind of see all the notes, all that fun stuff. If you find these episodes valuable, the best thing you can do on YouTube is hit the notification bell, or say hit the subscribe, then hit the notification bell, click all. On Facebook or LinkedIn, please share this with your contacts and tag at Smart Buildings Academy, all one word. If you're on iTunes or Spotify, please consider leaving us a 5-star review if you feel like we've earned it. Okay, I do know episode 452 is not up yet. I got thrown off this week when I damaged my phone on Sunday and then had to change my podcast schedule and everything. But 452 and 453 will actually be up shortly after these recordings. So let's dive in. I got a bunch of questions after we did our BACnet discussion last week. And so what I want to do here is talk through BACnet IP. For that, I'm going to share my screen. Let me go to share, pick a application here. I am going to share Workbench on the screen right now. If you're using a different building automation software, that's totally fine. This is less about the building automation software, and it's more just about BACnet IP. We're going to be going through a bunch of different stuff. We're going to look at Wireshark a little bit later, but for right now, we're going to look at BACnet IP. All right. So if you recall in my earlier episode, I talked about, I think it was episode 449. I talked about how BACnet IP, its address is its device ID plus its IP address. Now, as I said on Tuesday, if you're listening to this, you need to understand subnets. So it shouldn't be a surprise to you when I say that we're using an IPv4 address. We are going and having to understand our IP address. We have to understand our subnet. And we have to make sure that our IP addresses, if we're not using BBMDs, which we'll get to later, are on the same subnet for reasons that we'll get to later. But first, I want to go into BACnet IP. So BACnet IP is a protocol. It exists off of port 47808, which is actually called port 0xBAC Bravo Alpha Charlie 0. That's the way of saying UDP port 47808. Now, a lot of you are wondering, like, what is UDP? What is TCP? So I'm going to bring up something real quick. Give me just a second. smartbuildingsacademy.com, OSI model. This should bring up an image. Okay, and then let me grab this and let me throw it into the stream real quickly. Share, window. There we go. Share that and show on screen. Okay, so if we go here, I click into this, open image in new tab. All right, so you'll often hear me say a couple different things. You'll hear me say layer 1, layer 2, layer 3, layer 4. And you may be like, what does any of that mean? Well, layer 1 is the physical layer. It's the wires between our nodes, which if you watch Tuesday's session, this makes sense. It's between our nodes our computers, our controllers, our supervisory devices, and our network gear, our switches. Now, between those, we have what is called the data link. And this will become important when we get into the BACnet virtual layers and we talk about what are virtual BACnet layers and how do they work and why do we have them. But suffice to say, for our BACnet IP communication, we are using Ethernet cables, typically, between our controllers and our switches, or our supervisory devices and our switches. And data link is the layer at which the Ethernet messaging occurs. Then we have our network, and you'll notice there's types, right? So for data link, it's frames. For the physical, it's ones and zeros, and there's different ways you can do data encoding, like a 1 means on or a 1 means off, but that's not pertinent to BACnet. Data link, we know we have Ethernet frames. These are going to contain the MAC addresses. When we get into Wireshark, this is going to make a lot more sense. Then we have networks, which are packets. These are going to be our IP addresses. And this is where a lot of our routing, our subnetting is going to happen. We're going to see that this is the layer at which our device address is set, our BBMD addresses are set, and our BDTs, BACnet distribution tables, are set. These are IP addresses. And the concepts of subnets and IP address range, things of that nature, that all comes into play here. Then we have the transport layer. It does say TCP, host-to-host flow control, stuff like that. Interesting thing, if you've ever downloaded a file from a remote source and you've noticed the download gets faster and faster, then it slows down, then it gets faster and faster, you're actually witnessing flow control. What happens is with transmission control protocol, TCP, there's actually message acknowledgement. So it grows the size of message, the network grows the size of message as it sends it. And if it doesn't get an acknowledgement, then it dials it back down. That has overhead, but it ensures that people are getting messages and they're getting them in the order they need. Since we want BACnet to be a light protocol, it's UDP. And UDP means connectionless. So TCP is connection oriented, meaning there's that connection between the two networking devices. And if messages are sent, we make sure that they're received and acknowledged. When we have UDP, user datagram protocol, if I remember correctly, UDP is actually a connectionless protocol, meaning that it's fire and forget messages. And you may be like, okay, but how does that work? Because we have services in BACnet that are things like read property, and they're a confirmed request or a complex request, and they require an acknowledgement. So how do we actually do a receive acknowledgement and send stuff back if we are using a connectionless protocol? And that's where we actually get up into the application layer, and that's where the BACnet virtual link and NPDUs and APDUs come into play, which we'll talk more about in just a little bit. But that's a brief primer when I say layers 1 through 4, kind of gives you a high level. Like I said, hopefully you came into this understanding what IP is and subnets are. If not, we'll do a future episode on those. But for right now, I'm assuming you know that. Okay, let's go back here to Workbench. So with all of that being said, right, we know that we're setting an IP address. So I would set an IP address. I would have a UDP port. 47808 is the standard port. However, you can use other ports. If you are using other ports in order for devices to communicate, you'll need to use routing devices. So there's routers and there are BBMDs. And I'll go through the difference between those because they often get confused. People think a BACnet router is a BBMD. It can have BBMD capabilities, but a router is actually different than a BBMD. BBMDs solely exist to manage our broadcasts, which are our discovery services, which we'll look at a Wireshark on that. But those discovery services are broadcast messages. And if you remember about IT networking and subnetting, a broadcast has a broadcast domain. Hence, the last address of your subnet is your broadcast address. And The thing about a broadcast domain in a subnet is broadcasts can't propagate past their subnet boundaries. BACnet found a way to work around this by using BACnet broadcast management devices and broadcast distribution tables. So you have broadcast distribution tables, and that's a table for every BBMD, and then the BBMD propagates that broadcast, that who is, I am discovery message throughout the subnet. You'll notice though, BBMDs, that's what they exist for, is those discovery messages. As soon as we build our BACnet node list, which is a list of our BACnet IP devices, so it's an array, and we build our BACnet node list. As soon as we build that, which we don't build that, the discovery process builds it, it's programmatic. But once that's built, then we actually switch over to unicast and multicast messages that are managed by the BVLCs, the BACnet virtual links, and the APDUs and NPDUs. I know this all is confusing. We're going to look at Wireshark and it'll make a little bit more sense. But you're kind of seeing the settings right here. Now you'll see routing enabled. And for the longest time as a tech, I really didn't know what BACnet routers were. I just knew I needed to enable routing if I wanted messages to be able to communicate to other IP devices. So I would go and set routing enabled, but I didn't really know what it was doing. And we'll see what it's doing when we actually go and look at Wireshark. So I'm going to go and we're going to bring up Wireshark. I just dumped a lot of information on you just now. So if you have any questions on anything I've brought up so far, please, by all means, ask away. I'd be more than happy. Let me check the chat and see if we have any questions so far. We're looking good. All right. Looking good there. All right. And I don't see where the live stream went on LinkedIn. That's okay. Oh, why is it saying we're in pre-live? We shouldn't be in pre-live. We should be in live. Let me make sure we're streaming on LinkedIn. Give me 1 second there. Why is it saying we're in pre-live? That is so freaking weird. We're live on YouTube, but it is pre-live on LinkedIn. I don't know. What the hell ever. I'm going to, give me 1 second, folks. I'm going to just share this onto LinkedIn. Hey, folks, for some reason, the LinkedIn live is broken. Please use the YouTube live. There you go. Huh. Weird. I don't know. Maybe if you all are seeing it on LinkedIn, let me know. But I'm not seeing it on LinkedIn. That sucks. I really wanted people to see it. God, man, technology. I swear to God. Anywho, back to the live stream. So like I was saying, we have BACnet IP. And BACnet IP, we're going to look at a read property. Okay. So I'm going to look at this read property. I'm going to shrink all of these little things here for the message. Okay, and we're going to start to expand. Now, remember, BACnet, I got thrown off by LinkedIn not working. Let me collect my thoughts. The OSI model, layer 2, Ethernet frames, right? So we see our frames. Not a whole lot for you to worry about here. The main things I look at when I look at frames is my destination MAC and my source MAC. And the reason I like to understand my destination MAC and my source MAC, if I do have a break that is layer 2 related, either it's a data link or it's something on the physical network, I will usually notice it here because I will notice that the destination where it's trying to get to either wasn't reached or is the improper destination or something. Most of the time, I don't have Ethernet issues. Then we move to IP. This is where we have our source and our destination. I'm not going to get into encapsulation and how source and destination work too much in detail, But suffice to say, when we're doing network encapsulation, the frame, right? Think of envelopes. The frame is an envelope that has the IP address inside it. And the IP address is an envelope that has the user datagram protocol inside it. And the UDP is an envelope that has the application layer stuff inside it, which is this BACnet virtual link. So the encapsulation and decapsulation, they work using those concepts. But what we're going to be primarily focused on here is our BACnet virtual link control. We're going to see we're using BACnet IP and XJ. We're seeing that we're using a Unicast NPDU, Network Protocol Data Unit. The importance of this, so what BACnet virtual links do, and BACnet links in general, is they enable us to communicate across disparate protocols. So if I'm a BACnet MSTP, and this is a BACnet IP capture, so it's not really going to illustrate it too well, but if I'm a BACnet MSTP device and I'm communicating to a BACnet IP device via a peer-to-peer share, that BACnet virtual link is going to encapsulate and allow us to go from MSTP to IP, and it's going to allow us to communicate across our BACnet networks. Typically, BACnet networks, IP networks, are unique IDs that signify a actual network, but I've seen people use the same network for multiple different subnets. The important stuff really is your BDTs, your ports, your BBMDs, your IP addresses, and your device IDs. But our BACnet virtual link control, it enables us to then do our network protocol data units. And this basically explains, like, what does this contain? How does it work? I'm not going to dive too deep into MPDUs. I am going to spend some time, however, in APDUs. So we're going to see our APDU will have the object identifier, which is what object am I writing to, right? It's a device, and it's 111. What property am I writing to? I actually want to read property. I want to read a point if I can find one here. Analog input. Is this a read property multiple? I think this is. Let me take a look. So here's my APDU. This is my complex acknowledge. I am reading. So actually I want this one right here because this is my confirmed require. So this is how it's going to start. When you do a read property, you're going to read the property and you're going to submit a confirmed request. So I need to request this information from this device. So right here, I have my read property from device 111. I'm reading it. I'm pulling an object list, and I am grabbing a priority array 25, it looks like, something like that. Then I get from that device a acknowledgement. And we're going to see that complex acknowledgement right here. So these are unicast messages, right? As we will see up here, virtual link layer control, it's a unicast message. This is why the BBMD and BDT no longer matter, because the device ID and its IP address are now in a database inside the BACnet stack. And it's using a unicast message to send directly to this and receive directly from this device. Lot to take in there. I'm going to see if we have any questions. I'm going to be pausing quite a bit for questions here. This is so frustrating me because this is like a really good episode that I think will bring a lot of value, and freaking LinkedIn Live isn't working. And that's frustrating. Whatever. It is what it is, right, folks? There's nothing you can do about it. At least that's what my wife, who's a therapist, likes to say. So we talked about 47808. We talked about the network communication. We talked about device instance numbers. Now we're going to talk a little bit more about BBMDs. And to do that, I'm going to go to File, Open, Downloads. Yeah, let's do that one first. BBMD on same subnet. Okay. So whenever you read Wireshark, you want to read it from top to bottom. This is the latest capture, and this is the most recent capture. You can see that they're number stamped, and you can actually follow the stream if you wanted to, but we're not going to do that. But what we can see here, we have our BACnet virtual link control, and we're going to register a foreign device. So this is just going and registering a foreign device. And then when we register that foreign device, we're then going to execute this who is. And this who is going to be sent out to all of that and be managed, or to that subnet. That foreign device should be our BBMD it's registering. If I remember this, I did not collect this. This is actually from Steve Karg's website. I believe that that's the BBMD that it's registering. And then it's sending a unconfirmed request, so it doesn't require a response because it's a broadcast and there may be no response. And then we get our BACnet virtual link result, right? So now we have this result, and this result is going to be boom, 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 boom. And we're going to start to see all of this come in. Our IAM device, here we go. So we discover our device, and then we go through. Can I draw the nodes and the flow? I don't think I can draw anything with this software, to be honest. I don't even begin to know how to draw anything on here. So I don't think I could do that. But suffice to say, it's just a broadcast. If you're familiar with broadcasts, it's a one-to-all. So it one device broadcasts a IP message to all. It's very similar to ARP, Address Resolution Protocol, on a switch. So it does this, and then all of these devices respond back. So we'll see that they respond back to whatever the device is. So let's see. And then once we get that, you'll see that we get a couple here, right? We have our who is being sent out, and then we have our respond back, respond back, respond back, respond back, respond back, respond back. And once we get all of this coming in, and this is actually the routing taking place, then we are able to build up our list. It's pretty straightforward. There's not a lot of complexity here. It's just a very simple broadcast, if that makes sense. Are you all following me so far how this works? This is pretty straightforward. Hopefully it is. BACnet, I don't mean to sound dismissive, but this isn't a terribly complex topic. It's just a very simple broadcast. Are there two devices with the same device ID? I don't believe so. Remember, that is right here. 24 is sending to 255, which is the broadcast address, and it's sending to the BACnet supervisor that's discovering it. So this is a response. This is an IAM response. It's the same device responding, but it's going and hitting here, and then it's hitting here. I believe this is the same device. Let me look at the Ethernet. Take a look. Broadcast FFF, Dell, broadcast. Oh, I guess they do have the same device. Same device ID. So you're right. You're right, OMB. This is two different devices. This one, oh, wait. No. Hold on. Dell is the source. Let me read this real quick. Destination is the broadcast. Dell is the source. Then Dell is the destination, and the source is automated logic. Okay, so it's going out without having an architecture in front of me. What I think is happening in this, and remember, I am not the person who created this network. but it is Dell is sending out the discovery broadcast, and Dell is getting the response from automated logic. That's what's going on. So the Dell is your BBMD. And what is this? Yeah, because we're registering this. And this is all on the same subnet as well. So hopefully that helped. Let me see if I can get a clearer example of this. BBMD results. Here we go. There we go. I think this is going to be better. So we write our BACnet distribution table, and then we get our result. We read the table, and then we get our result. No, see, this isn't even. This is less clear. I'm not going to go into that for you. Here we go. Oh, this is even more complex, because this is actually doing a discovery, and then it's going and reading a property as well. So this one will be even more confusing. We're just going to go right back here to our on the same subnet. But yeah, it looks like this is the same device right here. The source is this right here. And then the source is, so it looks like it has a dual NIC is what I'm thinking is going on. That's what I think is going on. Hence why we have 123. We have 18. That's why we're seeing duplicates. Hopefully that makes sense. All right, let me stop sharing this. So as you can see, BACnet, BBMDs and BDTs, it definitely helps, as OMB mentioned in the chat, to go and have our network diagram. It would make things a lot easier if I knew how things were laid out and how it was structured. But like I said, I didn't create that capture. But as you can see, once you've went and discovered your devices, now you get into the Unicast, multicast, and I'm going to see what we got. Here we go. Share my screen. Unicast, multicast, and broadcast messages, or sorry, unicast and multicast messages once we've discovered. So I want to see here. This should be, I want to find a BACnet right here. This should be what I'm looking for. I want to have a controller, and I want to have it, so it's going to go, and this should be BACnet, and then this should be responding MSTP. Perfect. Okay, so what's happening here now is I'm a BACnet IP device, and this is where the BACnet virtual link comes into play. Oh, shit, what'd I do? Oh, I thought that would zoom in, but there it is. Okay. This is a BACnet IP device, and I am using the BACnet virtual link to do Annex J IP communication, and it's enabling me to go and communicate with this device that is a BACnet MSTP device, device 86114. And you'll see when I click on 86114, now I've switched over to MSTP, right? And so MSTP is going to go and message, and then it's going to be able to go and respond. So I'll get all that back. And that will actually, so what will happen, right? I'll do my read property, and I'll get my acknowledgement. And in order for it to go and do that, I actually have to execute it on the BACnet MSTP side as well. So you'll see kind of how that works. Pretty interesting. All right, so up to this point, we're about 30 minutes in. We've talked about BACnet BBMDs. We've talked about BDTs. We have talked about Unicast and multicast. We've looked at a couple Wiresharks. We've talked about setting up our IP networks. And we've talked about virtual links. I will say that the big kind of challenges you're going to run in with this are broadcast traffic. So really managing your broadcast domains. You want to be strategic with your BDTs. You don't want every device to forward to every broadcast domain, especially if you have no need for, like, example, a supervisory device is never going to do peer-to-peer with another supervisory device potentially. Well, in that case, if there's no peer-to-peer communication, then you're not going to want a BBMD with a BDT on that one supervisory device to have an entry to another supervisory device's domain. Because if you do, then you're going to discover that domain, and you don't need that. Maybe you only need the server to discover everything, and then each supervisory device will discover its own little things. So just so you know, that's something that's really important. I will say network segment and scalability. That's something you also have to consider, but I'm not going to get into network design in this episode. And that's pretty much BACnet IP. There's not a whole lot to it other than what I just went through. If you all understand what I just went through at a high level, you should be competent enough to do BACnet integrations, BACnet IP network setup, etc. So I'm going to pause, see if we have any questions. Hopefully this helped. Hopefully this was clear. I apologize for my distraction. I don't know what the hell happened to my live on LinkedIn. I am not sure what happened and why it's not streaming. But yeah, it sucks. I was really looking forward to this. But yeah, it is what it is, I guess. So I can't oh shit. Could I have, let me see. Share stream. Yeah, it's saying that it should be. Hold on. I want to copy this and see if this is streaming on LinkedIn. No, it's still stuck in pre-live. You know, it's frustrating, right? When you go and you create something and you put this effort in and you're like, really, if I'm totally honest, I like sharing it on YouTube and I like sharing it on LinkedIn. And then I tend to get a lot of viewers on LinkedIn and then it doesn't work. And I'm like, it's so frustrating. To the point where I'm tempted to redo this and actually do this episode again. But I guess it is what it is. No, I know. I appreciate you all as well. So I'm glad you all attend. I mean, if just one person views this, in my mind, it's worth it because going and educating folks is something I enjoy. I actually was talking with my co-owner, and we were talking like, is doing the podcast the best use of my time? And I was like, no, I mean, there's not really this huge financial return from it. We don't really monetize it, but it's just something that is a creative outlet for me that I need as kind of a distraction from the day-to-day grind of being a CEO and running a business. This is something I just enjoy. I feel like it keeps me mentally sharp and makes me like really understand stuff, because if I'm going to run an org that's going to teach this, I should probably know it. So yeah, I hope this helps. I will see you all on Monday. We might be doing this episode again. I got to figure out why this live stream didn't go through on LinkedIn. It's very frustrating. As always, everything will be available, podcast@smartbuildingsacademy.com/453. Once again, that is podcast@smartbuildingsacademy.com/453. Thank you, everybody. And I hope you all have a awesome weekend. Take care.